Hey, this is Greg, creator of the Leptos web framework for Rust. I want to talk today a little bit about create effect and effects in general in a reactive system. And there are two reasons for this. The first one happened about a month ago. I kind of got into it with somebody on Twitter who was coming out of the React world and was talking about how they really appreciated the rise of fine-grained reactive systems like the prominence of Solid.js, pre-act signals, Quick talking about fine-grained reactivity. But they thought that these libraries shouldn't expose effects to people. And I kind of went back and forth with them a few times. I thought this was a strange perspective. I mean, how do you work with a reactive system if you don't have effects that can respond to it? And it turned out that they were just so badly burned by use effect in React and all the strange behavior that comes along with that, that they were kind of bringing that baggage with them into a fine-grained reactivity. So I want to talk a little about how this works in a fine-grained reactive system like Leptos, how create effect is different from use effect in a sense, and how it can actually be a really, really powerful tool for certain tasks. Then about a few days ago, I got a bug report from somebody who was saying, hey, this thing, this code, which I think should be safe to unwrap, it's panicking, I think there should be a value here, but there's no value here. What's going on? And I looked at it and I said, I probably wouldn't have written it that way because they were using an effect to set a signal depending on another signal. And I thought, what if I do a derived signal? Yeah, and sure enough, the bug went away. And this is something I tell people not to use effects to write into signals all the time. It's actually in the create effect docs, but I hadn't had such a clear example of why it was a bad idea until then. So if you want to know when to use create effect and when not to use create effect, there's actually a really simple rule. And it's this. This is right in the create effect docs, but do people read docs? I don't know. Basically, you should use effects to synchronize the reactive system, your signals, your derived signals, your memos, with non-reactive APIs outside that, like the DOM, like the console, like the fetch API. So in other words, if you have a signal and in response to changes in that signal, you want to do something that's not part of your reactive system, create effect is perfect. However, on the other hand, if you're trying to synchronize state within the reactive system, if you have a signal that changes and you want another signal to be updated, create effect is actually not a great tool. And so my kind of principle is use effects to synchronize the reactive system with non-reactive APIs, not to synchronize state within the reactive system. Let's jump into an example to see. I'll show you first when create effect is really powerful. And I'm going to be using CodeSandbox. I'm really excited about this CodeSandbox Rust support. It makes it really easy for me to share code examples with you. And it has great Rust analyzer support and stuff. It's almost like you're in an IDE. So really cool. So this first example, right? Imagine, I said to this person, imagine that you have a chat application and people can set their own display names. So you want to set your first name and your last name. And then let's say you can, choose whether you want to display your last name or not. This is kind of a silly example, but whatever. Every time your display name changes, you need to notify the server, right? So imagine that instead of this log function here, we were calling something that was like sending a message to a WebSocket or something, right? So every time the name changes, it needs to update the server. This is pretty easy to understand, right? So if I type in my name, Greg, it sends a message Greg. Johnston sends a message Johnston. Obviously, if I change my first name, it'll change that. Change my last name, it'll change that. Now let's say I uncheck this show last name, right? So now it's just Bill. Now if I change the last name, nothing happens. Because I've unchecked show last name, my display name doesn't change. And so when I change the last name, it doesn't need to update. Now, if I toggle show last name back on, it will immediately send a message to the server with the correct last name, and it will start logging my full name again. Now, the reason for this is pretty simple, but it's pretty cool once you understand it. Let's look inside the code. So we've got three signals here, right, which are just first, last, and whether to use the last. And we just assign them to three inputs: a text input for the first name, a text input for the last name, and a checkbox for the used last name. This is really simple. What's actually interesting here is this effect, right? So when we create an effect, it immediately runs. And so it immediately actually logged out a blank line because my name was blank, if you see this space here. And when it runs, it subscribes to any signals that are accessed inside it. So basically it pushes itself onto a stack of running effects. And I just have this code. I'm going to log if useLast is checked, right? This is a Boolean read signal. Then I'm just going to do a format string, and I'm going to take the first name and the last name, smush them together. This is not good internationalization, I understand. If useLast is not checked, I'm just going to use first name. Now, you'll notice if you've ever used Leptos or if you've used Solid or Sycamore, there's not an explicit dependency array here, right? I don't need to do something where I do like first, last, use last, and pass those in like I would in a library like React to tell it that when one of these has changed, you should rerun this effect. No, it does automatic dependency tracking, right? So what that means is pretty simple. When I run this effect, I push it onto the stack of effects. When I access any one of these signals, it checks, okay, well, what's on the top of the stack of effects? If there's something there, it says, okay, yeah, subscribe that to me. So now whenever I change, whenever useLast changes, we're gonna need to rerun this effect. So then we go down, it started as true, so we do this format, and it accesses first and last. And likewise, first and last tell this effect, subscribe to me. So now it's subscribing to three things, right? So whenever first name changes or last name changes, it will rerun this effect. It will log again. And we saw exactly that behavior. First name changes, it runs. Last name changes, it runs. Now it's also, of course, subscribed to useLast. So if I change to useLast, it reruns. But before an effect reruns, and this is really important, before an effect reruns, it clears its dependencies out. So when I rerun this effect, it unsubscribes from all these signals, and then it resubscribes. And if I run one again, it unsubscribes and it resubscribes. And that may seem kind of inefficient, but here's why we do this. So when I unchecked this, it unsubscribed from all the signals. It ran the effect again. It hit if useLast, and it was false this time. So it went to the else branch, and it accessed first. So now my effect is only subscribed to two things, right? Because it's cleared out those three dependencies on useLast, first, and last, and it's resubscribed to useLast. It goes to this branch, and it resubscribes to first. So now I can update last as much as I want. I can edit this text field, right? And every time I change this text field, it's actually setting that signal, that last signal. But this effect is no longer subscribed to that last signal, right? So I can change last as many times as I want, and nothing happens. But then when I tick this show last name back on, it clears out the dependencies, it runs the effect again, it checks useLast, that's true, and now it resubscribes to first and last so that it can create this string. And so create effect is not just automatic dependency tracking, it's automatic and conditional dependency tracking, which means that the dependencies aren't just a static, not only do you not have to pass in this explicit set of the dependencies, it's actually not a static set of dependencies. The list of dependencies depends on the actual logic within here. And there's a sense in which this is suboptimal, right? Because you're unsubscribing and resubscribing to all of these signals. And you could say, well, why not just subscribe and rerun it optimistically, even if it doesn't actually need to? It won't have to do the whole unsubscribe and resubscribe. But the reason is that the point of create effect is synchronizing reactivity with non-reactive APIs and running side effects, which are typically more expensive than throwing around a couple signals in the reactive system. So the whole point here, right, is that while this isn't a zero overhead abstraction in the traditional Rust or C++ sense, right, while this does things like subscribing and unsubscribing from effects, doing the stuff in the reactive system, if you step back a layer from the perspective of your API, from the perspective of the side effect that runs or doesn't run, this create effect is actually a zero cost abstraction in the sense that it will run precisely the number of times that it needs to. It will not run that side effect again, which may be expensive, maybe making a request to the server and then having the server send that information down to a bunch of other clients, right? It won't do that if it doesn't need to. So if I have, just to show it one more time, if I have this unselected, it's not that I'm memoizing or something. This literally isn't subscribed to that last name signal. So it just runs the side effect as few times as possible based on what you've told it. So I sent all of this to this person, right? And they said to me, yeah, fine, but you don't need an effect for that, right? Why don't we just use the platform? And you don't need 3 separate signals doing these controlled inputs where you've got this prop value in and this on change event. Just use a single change event on a form. And we said, okay. So they implemented, they sent me like 5 or 6 versions of this that were all kind of not ideal. I made one based on the kind of final version. So we're going to reload the page. We're going to swap in this manual version. Now you'll see this version's a little bit different. What I did here is I created node refs for the first name, last name, and used last name. Right, and we just assign those down here. So these are what we might call uncontrolled inputs, right? Where the browser controls the state of what's in here. We're not updating a signal and then passing it back through. If you're familiar with the idea of controlled and uncontrolled inputs from something like React, you'll recognize this. If not, I actually just created a little tutorial CodeSandbox and I'm writing something up for it. So you can check that out upcoming soon. But we've got all these form inputs, right? And then we've just got one onChange listener on the form. And then here's the onChange listener, right? So what it does is it takes these 3 node refs. They each have the type of an input element. And first, we just get these, and it's safe to unwrap a node ref like this in an event listener. It's none if it hasn't been filled yet. But of course, by the time an event is being fired, they all have been filled, like the DOM has been created. So we're just going to unwrap them here. And then we log out, right? A similar function, if usedLast.checked. And you'll notice usedLast here, because it's typed as an input element, we actually can use this native checked getter on it. It kind of derefs into a WebSys native DOM element. And then we format, first.value, last.value, else first.value. Great, so this looks really similar, right? Greg Johnston, Bill Johnston, Bill Smith, perfect. Uncheck it, Bill. This is great, right? Maybe we don't need an effect at all. Maybe we can just do it with event listeners. Why complicate things? Okay. Thompson. So we log Bill again. We log Bill again. CodeSandbox refreshes on me. Greg Johnston, uncheck last name. Smith, we log Greg again. Jones, we log Greg again. Thompson, we log Greg again. And this makes perfect sense, right? Because every time any one of these 3 elements changes, we fire this onChange event. And it gets the value of each of them and it logs it out. So this, in a sense, right, it doesn't have that create effect, but it's actually less efficient, right? Because it's sending more requests to our API. Now, if you're at all thinking about this, you know that we can just memoize this ourselves. So we can say something like let mute prev name equals string new. And we're lucky, we don't even have to do interior mutability or an RC here or anything because we only have the one event listener, right? Which is the reason to do it in one event listener. And then we're gonna have to pull this out, right? So we'll say like, let this one equals that whole thing. And then we can say like, if this one is not equal to previous log cx this one, and then prev equals this one. And this should, assuming I did it right, well, it's called prev name, of course, prev name. So assuming I actually did this thing properly, right, it should now behave in the way that we're hoping it will, right? And it'll send the minimal number of requests. So we've got Bill, Smith, Jones, set last name, Thompson, right? Okay, because now what we're doing is every time it changes, we're still rerunning it. So when the last name changes, this listener is firing. And I could even make that more explicit by putting another little log here, right? But basically, because we're memoizing it, right? Because we're checking it against the previous name, we're not running that side effect. And if it's a side effect that's expensive, fine, right? Like running the listener is not expensive. So you see each of these times the listener is running, but it's not actually logging it out. And that's fine. That's a fine way to memoize this, to not send stuff out to your API more than you need without doing a create effect. whatever. The point is, right, you have to manually memoize it, and you have to manually do the check here. And why? Why? Like, there's not a good reason, in my mind, to avoid the create effect here, because create effect isn't a foot gun like it is in a library where you're rerunning this whole thing as a render function. Like, in my mind, there's just no reason not to use create effect, but here's a manual way to do it. All right, so create effect is great. We love it. When should you not use create effect, right? When should you not use create effect? So here's a good one. A good example would be, let me re-render the app for a sec here with this effect versus derived signal component. So we're going to start with my one that's commented out that says, don't do this. We'll get rid of do this. So this is an example, right, where somebody, just to show you what they're doing, they have my value, which is a string, and then they have my optional value. We'll get to that in a sec. Whenever you change anything in this input, it sets my value, right? And then they show, my optional value, and it is, and then they use this show component. This is one of a new control flow component we have. It's in our Git main right now. I don't think it's actually been released in one of the releases yet. But basically, it says this is similar to what works in solid.js. It says show when equals my optional value dot is sum. So in other words, you say I only want to show the children of this thing. I only want to show this body when my optional value is sum, not when it's none. Great. And as a fallback, I want to show the text none. So in other words, if this condition is false, you show none. If this condition is true, you show sum, and then my optional value dot unwrap. And if you are used to Rust, right, you'll see this and you say, unwrap makes me feel icky. However, they are checking whether it is sum, so it should kind of be safe to unwrap down here, right? And if you actually run this code, I'm going to have to save this and hope it refreshes for me. But if you actually run this example, what we're going to see, it's going to be a little hard to see it. And let me just make sure that this is the non-working version before we do it. Yeah, okay. So this is the version that doesn't work, right? As I type value, great, my optional value is some value. What they've done is they've created an effect here, and they say if my value is not empty, set optional my value to sum my value. And if it is empty, like if it's an empty string, set optional my value to none, right? So what they're trying to do is basically convert between a string and an option string, and they want the empty string case to be none, and they want anything else to be sum, right? So you can see values, it's updating it, it's fine. And if you change it to, oops, that doesn't count. Oh yeah, this is already crashed, okay. If you change it to value, it's a little hard to see what it's doing because I don't have the console open, but this is actually panicking, right? And then you'll see it kind of like restarts over here. Like this is clearly bugged out, but this is actually panicking on the unwrap. And you'll say, well, why should that be, right? Shouldn't this show when it's checking my optional value? Shouldn't be guarding against this? And so they open a GitHub issue and I say, okay, this isn't how I would do this normally, right? Like the create effect docs say, don't use an effect to write into another signal to synchronize state within the reactive system. So what if we do it instead with a derived signal, which first of all is fewer lines of code, saves you an effect and saves you a signal, which do cost something. They have a small overhead to create. So I say let my optional value equals, and then this is just to save me a string clone, right? If not my value.with string is empty. When you use .get, it clones the value and gives it to you. When you use .with, it applies a function to it. So I'm just using string is empty. This is the same thing as saying .with n, n dot is empty. It's just a little, I'm being fancy, right? But so if it's not empty, return some value.get. And here I clone the string out and put it in there. Else none. And when I do this version, what you'll see is that it works. Value, none. Values, none. So what the heck is going on? It took me a while to think about this and try to figure out what exactly was happening. And I think what's happening is this. The show component is actually really, really simple. If you want to see how the show component works, it's literally just these lines, right? And the first thing it does is it creates a memo around that when condition. And the point of this is that what that does is, as long as this is sum, it doesn't constantly re-render this body. So the memo is a memo around this, which will only trigger when my optional value.isSum changes. So the when doesn't re-render this every single time that you type a character and it is still sum, right? Instead of re-rendering it, it just keeps this. Okay, so it creates a memo around the when, and then if that's true, it returns the children, and if it's false, it returns the fallback. And these are both functions, so it calls it to render it, and then it returns it as a view. Super simple. So I think this is what's happening in this case. When you put this in here, right, this actually returns a function, which the renderer wraps in a create effect. So when this create effect runs, right, think of a create effect wrapping this function. Now it depends on memoized when. That's its only dependency. If it's true, it depends on any children you access inside here. And if it's false, it depends on any signals you access inside the fallback. Okay, so when this is true, this depends on my optional value, and it depends on my optional value. Okay. So with the way we've written it here, right, my optional value is one signal. It depends on my value, right? Okay, great. So my optional value isn't actually a signal the effect can subscribe to. So the effect around the show actually just depends on my value. So whenever my value changes, this will rerun. And it will do this memoize check on the when. And if this is sum, well, then it will render this. And when it falls back to being none here, it's false, it goes here. But there's only the one signal. That one signal is my value, right? In this situation, where you're creating an effect, and you're creating a second signal, and you're writing into it, you'll notice when I wrap the show around this now, it actually only depends on my optional value. But my optional value is a signal, and my optional value will trigger whenever this updates. And you're not necessarily guaranteed the order that an effect asks for the signals, or rather, put it this way, my optional value, right, is what it is depending on here. And it's almost as if because you've created another effect, it's created this intervening step where like my optional value gets triggered, and it's almost as though it's really hard to describe. The ordering is off when you have this intervening effect and a signal in a way that it's not when you just have the derived signal. And it's like really hard to explain exactly what's going on here. But I thought it was uncanny that when I changed it from what I have recommended explicitly, right, that people not do, which is use an effect to write into a signal, to what people should be doing, which is to derive a signal like this, it just worked. And so, I think I would need to dig a little bit more to understand exactly what's happening, that these are both running. But I think what's basically happening is that, the children here is like, the effect is still, something, right, this getter is still running and it's still unwrapping because there's this effect that's triggering it to run again. And again, like it's really hard to explain exactly what's happening. Intuitively to me, it makes sense. And I'm just babbling on a YouTube video now. But like this derived signal is the way to go. And so the idea, right, is you have signals, and then rather than this multi-tiered thing where you have effects writing into signals in response to themselves, you just have a function that accesses it and does whatever transformation you want. We could actually make this even simpler. I don't know This is kind of up to you whether you think this is a better way of doing it or a worse way. But we could actually do, right, not myValue.withString that is empty. We could do like .then sum myValue.get. That should work, right? I hope that cargo format will fix this formatting for me. Like this is really like a one-line statement. I mean, maybe you don't want to write this as a one-line statement, but you don't need another signal and an effect that's 6 lines. You know, it's a really simple piece of logic to write, I guess. So that's basically my summary, right? To go back to the principles, right? Use effects to synchronize the reactive system with non-reactive APIs, like that first example where we just instantly got that memoization, that zero cost interaction with the API for, you know, without having to write that explicit memoization ourselves. And as it scales up in complexity, as we're accessing more signals, it still works. Don't use it to synchronize state within the reactive system because you might create these weird, hard to debug, hard to understand chains of effects where setting the initial thing is running an effect that updates another signal in a way that's difficult for you to reason about. Just use a derived signal. It saves you in every single way relative to using an effect to write into a signal. So yeah, I hope that helped clarify some of how create effect works and when you should and shouldn't use it. And I hope you all have a great day and are out there creating great applications. Take care.